Hello, welcome to my channel. In this video, we are going to be solving problem under torque. And the problem we are going to be solving has the diagram of this form. So, the question that can arise from this diagram is giving us, what is the least force F needed to pull the wheel onto the curb successfully? The least force. So, to solve this problem, we need to consider certain label that are missing from this diagram. So the first one is this height here. We know from here to here is the radius of this wheel. And if here to here is the height of this curb, then from here to here will be r minus h, which is giving us r minus h. Then we also need this length from here to this point, right? And to get these points, we know that this side is also equal to this length, and we can label it x. And to find x from this side to this side, we know from here to here is r. We know from here to here is r minus h. Then we can determine this one using the Pythagoras theorem, which is giving us r squared equal to, that's r squared equal to r minus h squared plus x squared. So if I make x the Sevier formula, I will get this. If I expound, I will get x squared equal to this expression. R squared cancels r squared, and we get our x to be equal to this expression. So now that we know our x to be equal to this expression, then the next thing is to apply torque, because this force is needed to upturn this particular wheel over this curb. So for us to find the torque, that is this force times this perpendicular distance, then we use FTC equal to FR sin theta. This is the usual formula for torque, where our R is the radius from this point to this point. Then our sin theta is this angle here that this particular force is having towards this particular radius. So to find our sin theta, which is this angle, we know that this side will be equal to opposite all over hypotenuse. Opposites, right? All over hypotenuse. So, and that gives us r minus h, which is r minus h all over this r. Then r takes care of r. So our TC, which is clockwise torque, is giving us TC equal to F times r minus h. So let's look at the anti-clockwise torque. That is the torque needed to pull backward. If this one is needed to pull over this curb, this one is needed to pull backward. And the force acting back that is moving in the anti-clockwise direction is the weight. So the weight, mg, times this perpendicular distance, which has been determined, which is this one, is given by, first of all, we use mg r sin theta. And what is our sin theta here? This is the weight. This is the angle made with this particular axis. So if you find this, if this is our theta here, then opposite all over hypotenuse, this side is our x all over this r. So we get this expression, which is our x all over r. So our r cancels r, then our anti-clockwise torque is given by this. Now that we have found the torque for the anti-clockwise and clockwise, for equilibrium to occur, this torque must be equal to this torque, and that is given by torque. The clockwise torque must be equal to the anti-clockwise torque, and we have already found TC, which is this, must be equal to TA, which is this. So we can make our F the Sevier formula, and we have F equal to mg, this expression all over this, right? So this is the force needed to pull that thing over the torque. The least force will just be a little bit greater than this or equal to this one, right? So let's find out if our M is giving us 1.5 kg, R is this, and our H is 0.1 meter. What will be the value of F? So if we fix them in, we'll get F equal to 1.5, 9.8, and this expression. So at the end, we have our F equal to 5.79 Newton. So this is the force. So something a little bit above this one is just the force needed to pull that wheel over the curb. I hope this helps. Please like, share, and follow. Thank you.